Hello, my name is Thomas Lighthome and this is my shader developer tool for Comp 3015 Games Graphics Pipelines. I have developed a simple program what utilizes multiple shaders and you're able to navigate through the different shaders using a GUI menu. So for example, we have night vision here. We have a little bit of information talking about how I was able to make the night vision shader. We have some settings here what we can go through. So we have camera zoom, we can rotate, or we can change the actual mesh itself. Each mesh has its own textures, so for example R2D2 has its own texture, the gun has its own texture, and the car has its own texture. So now if we go into our next shader, Spotlight. So Spotlight here, you can see we have the spotlight aiming down on the ground as well, just so we can show the reflection and how it has been developed. Here we have information talking about how I was able to make the shader. We can change the skybox, and we can change the surface animation. To access all these buttons and GUI elements, you just use the left mouse button or the scroll wheel for the information. I've also decided to include the frames just because sometimes it drops down in frames to adjust, so I thought that would be a nice tool to include to show how the program is running. So if we go into BlingFong, as you can see, similar to the previous shaders, this is how BlingFong is applied to the mesh. Let's change to triangle, we'll change to lava world. As you can see, our surface animation here, what was previously water, is now lava because we're in the lava world. So we go into edge detection. So now we use a different shader, but because we can change them at runtime, you don't even notice the change, only the visual change. So here you can zoom in and see the edges. You can change the model. So now if we go into wireframe, our final shader. So here we have a little bit of information as well, like the previous shaders. But you can see how the wireframe is produced using geometry shader as well as vertex fragment. So here we can go through and change it. So yeah, this is how the program works. I'll basically now go through the code itself and how I was able to make this tool. So this is the bulk of our program. So we have all our variables here. We basically load in all our meshes here. Before we start anything in the program, we compile all our shaders. So this is done here. So here we compile every single shader and we link them to the program. We don't use them yet. We basically, what we do, we use them when we start using the actual shader itself, just because it will come up to be like a big mess of using every single shader all at once. So we enable our depth testing, set our initial projection and view. We call our get textures method. So here we load in all our textures. We start using the night vision shader because this is the first shader we start using, and we call our initialize night vision shader method. So our update is quite basic. It's basically if the camera is rotating, then our rotation amount equals our time, but if it's not rotating, it will equal 0. And we'll call the render GUI method. For the purpose of this, we don't actually get marked on the GUI, so I'll just quickly show the code, but I won't go into detail about how it's done. So in our render method, this is where basically the bulk of our project is. This is where we basically change shaders at runtime, change the meshes, the skybox, and apply surface animation if possible. So basically we set our initial view position and our rotation, we clear the color and depth buffer. So for shader index 0, this is the night vision one, so we start using the night vision shader. We do our first pass and our second pass. I'll go into detail about that later on. Our first shader, what is our spotlight shader? So start using the program. Because I've done the spotlight shader and the BlingFong shader in one shader itself instead of separate, I set the shader index to 1, so if it's 1 it will start using the spotlight method, but if it's 0 use BlingFong. Set its uniforms, set its spotlight position and our light position and send that to be uniform. Here we basically do our different models, so if model index equals 0 it would be triangle, activate its texture and send its uniforms. And then if it's 1 it will do the same thing but for the car texture, and set its car like on mesh position for that. If it's 2, it'll be R2D2, so it will do the same here. And then if it's 3, it'll be the gun, and we'll do that here. And for spotlight, to show how the spotlight reacts to the mesh and itself, I want to implement ground as well, just to show how it reacts to the mesh and the ground as well. So I've got this method here to basically do the ground. And because Blingfong and Spotlight have liquid animation options on the GUI, we call our liquid animation method. Shader index 2, so this is our Blingfong. Same again, we enable it, we clear it, start using the program, set to 0, so we start using the Blingfong, send its uniforms, and then same again for the mesh, 0, triangle, 1, so forth. And then liquid animation again, this is only done for the Blingfong and Spotlight. For 3, we do our edge detection, and because our edge detection is done in 2 passes, we have it here. So in pass 1, this is where we do our mesh. Pass 2 is just sending our matrices again to be uniform, and then we initialize at beginning. Same again here. We do the setup wireframe here. We start using wireframe shader. Send the viewport. Oh, sorry. And then do our meshes here. Set skybox, that basically is just sending the MVP to the skybox shader, and our GUI render. For liquid animation, so if we want to use liquid animation, it will have an index of 1. So we basically start using it, we send the time uniform. If it's the lava world, it would be lava animation, but if it's just the forest or the city one, it would just be water. Send all its uniforms to the shader program, and then set matrices, send that to the shader, and render our plane. So obviously GUI isn't getting marked for this module, so basically I'll just slowly go through the GUI here. So camera zoom, camera rotate. This is how we change our mesh at runtime. This is how we change our skybox at runtime. This is how we apply surface animation or not. I got our frames here. For this one we can change the shader. And we'll have the shader type, and we'll have all the different shaders here. Then our frame 3, this is basically just our shader title, so what the shader is and description about what the shader does. And this is done here, so night vision, description, spotlight, description, Blingfong, description, and so forth. Our set skybox, so we start using the skybox shader, and then we send our MVP to the skybox shader, and then we render the skybox. Our set matrices, we pass in what shader program we're using, and send the data to the shader we have passed in. So just as we did for the edge detection, we have our initialize stuff here. We use the night vision shader differently, so we basically use our subroutine, and we send our data like this. And before we do any of this, we do the night vision FBO, was done here. So quite similar to the edge detection because they're both done in different passes. Just close this here, and then pass 1, similar to our pass 1 before. We're sending all our different models and setting up the textures. And for this shader we do a ground model, so we do a texture in here. And for our second pass, similar to the second pass of the edge detection, so we activate primary texture, we disable depth testing, we do the subroutine, we do this. For resize, this is basically called for every single shader, and basically sets its projection. And then for wireframe we have this stuff here. So now I'll quickly go through each of the shaders and how I'm able to get the shaders working after sending the data from this file here. So here is our vertex shader for Blingfong and Spotlight. So we got our in variables, we got out variables we pass out. Here I tried to do like diffuse texture as well as just the original texture, but I couldn't get it to work, so I've got a bit of code here explaining how I was able, well, I tried to do it. And then for our fragment shader, so we got the in variables passing from here. We got our different structures, so our material structure, our light structure, and our spotlight structure. And shader index here. So if the shader index equals 0, we call the bling fong method here. But if the shader index equals 1, we call the bling fong spotlight method here. So here I've got some comments here for our edge vertex shader, so it's just quite straightforward, we're just setting its position. And for our fragment shader here, we got our different structures, our variables. We call a bling fong method. We have a luminous method here. And obviously because edge is done in 2 passes, our first pass we're basically just returning a bling fong method. But for our second pass we call it luminous. We're doing it for each of the pixels. And returning here. And here we've got if pass 1, frag color equals pass 1, if pass 2 equals pass 2. So the same again, our vertex is just to set its position for our night vision one. And for the night vision shader, we have a different structures, our different uniforms here, what we pass in. So similar as before, we got a luminous method, a Fong model method here. And then for subroutine here, so if pass 1, we call the Pong model, but if pass 2, we call this method here, where we basically set the noise texture and the color texture, and basically give it that green, like goggles look effect. And then we've got if frag color equals render pass. So for our wireframe vertex, same again, we're just setting its position. We have our out variables here. Because wireframe uses geometry, we have a geometry shader here. So this is our main, where we basically get its viewport matrix. And I have included comment code here to basically explain the program and how it's done. So for our water shader vertex, it's similar as all the other vertex shaders. So we've got all our different structures and variables here with our comment code to explain what they all are. And obviously before we were just setting its position and all that, but because we're trying to get this animation like effect to make it look like waves, we've also using our time variables here and computing the normals and everything like that here. And for our fragment, we use a bling fong method, so we have a light structure, a material structure, and it's just basically bling fong method really. So for our sky vertex, our last one, because we're only passing in the MVP, this is how it's done here. And for our fragment, because it's just a texture being applied to frag color, we just do it like this here. So that's the code walkthrough for our shader program. So the reason why I chose to do it the way I did was because I wanted to make a program to teach people who are new to GLS shaders what they are, basically go through all the different types of shaders. You can view like different meshes and zoom in and zoom out. I just thought this is like a good learning tool really to give to people who are new to the program and the coding of like shaders, and just to learn what shaders really are. So quite a lot of information to cram down into a 5-10 minute video. I've slightly gone over, but yeah, hope you enjoyed, and the code will be on my GitHub. So yeah, take a look and hope you enjoy. So overall, I'm quite happy with the program. My first initial idea was to basically just have bling fong or spotlight, but when I managed to get them working, I saw potential to add more shaders. And then as I started to go through different shaders, I started to realise this is more like a learning tool really. So I thought to make it better suited as a learning tool, I included this information here, what you can read when you pass in different shaders. Just so now people can run up the program, see the different types of shaders, how they're done, We can see how the different shaders are used on different meshes. We can see how skyboxes are used. And we can also zoom in and see the different, for example, wireframe lines, or different lines for edge detection, or how the night vision is working. So yeah, essentially I basically built this program to be like a learning tool.